this case, holding. It's holding a value. So A is the label for this point. Okay? It's the label for that location. This is A. A is this thing. Maybe I'll sort of write it like that, right?
Okay.
This thing is A.
Okay.
Now, what I said is that we had an A down here that was 2, excuse me. And then we called off to something, we passed in an argument, and this was 2, and then this got assigned to 5. But, again, this is a different A, and then this guy is going to return. This guy goes away, that guy is still 2. So when we make this call, this thing labeled A up here is 2 as well. Because this guy is passed value 2, just passed the value. So only passed the value, passed the value 2, number 2, and that goes into a location called A, a new location, which lives up here, and then that location is assigned the value 5. Okay? And so this location is assigned 5, but that doesn't change what's in that other location. It's 5, right? And then this code, once it finishes, goes away. And we're back to that. That's the call stack. That's this guy here. Does that make sense?
Yes.
Okay, so, but let me ask this though. Here, okay, so you asked a critical question, but I want to make a key point about this. So we've been talking about values here, and you asked a really good question about whether it's the same or different, right? We just rehearsed how this goes. But let's say we did something different. Let's suppose that A down here holds a reference to some person, okay? Holds a reference to Al, okay? And let's suppose that we called another method that took that reference to Al and then assigned a different reference to A here. So it assigned a reference to this guy here, like that. Would that change this reference at all? And then we got rid of this. I would argue that no. We could actually assign, whether this holds a reference or not, is actually not directly material, but you've got a really good intuition because there is some other way that this guy can be interfered with. So if this guy was simply, so if we had my method, and it assigned, so it took in a person, call it, I'm going to call it just to avoid sort of confusion, I'll call it P, right? Just so we're not sort of mixing apples with oranges, mixing people with numbers. If we had something like this and P equaled Joe, or something like that, we pointed to Joe, and maybe this is Joe here. No, it's Al.
Sorry. I thought it was Al, but that's okay.
Yeah. I'll call it Al. Okay, this is Mr. Capone. Okay, so there we go. There's Al. Okay. Here's Al. And Al is this thing is say referring to. Okay. Wait a minute. So originally this is pointing to Joe, and then up here we call my method, and this gets now instead of being so initially we call my method. Suppose we call my method with that pointer to Joe, right? A reference to Joe. I call it. We had a reference to Joe earlier here. I'm just making it totally parallel to this. J equals Joe, and we passed it J. So we have P equals Joe. We pass it P to be consistent, and we pass it here. So P is referring to Joe here. We pass the value of P, the reference to this, to the method, right? So now P within my method refers to Joe. And then suppose we were to have P, set P equal to Al here. What would happen? Here's Al up here. Now P is going to refer to Al here, right? But Joe has not been modified in any way, right? But I'll tell you what would have screwed things up. In what case could could Al be modified? Or, sorry, could Joe be modified? How could...
If you deleted Joe, basically.
Yes, if you deleted him. Now, it turns out you can't do that at Java for safety's sake. You could do it in C++, but it's kind of like you could, you know, with the chainsaw, you could cut your arm off. So Java, they prevent you from doing that. But what you could do is you could, for example, in my method 2, malicious my method or whatever, you could actually say p.name equals Chris or something like that. So you could actually, if you had this reference to Joe here, so if we had p equals some reference to Joe, right? And then we call my method 2, right? My method 2 on P. So initially, we're calling this is a, I should say person P, to be consistent here, person P, right? Initially, when we make this call, person P is here. It's a different person P. It's a name for a different location. It's referring to Joe initially because we passed it at this pointer, which is referring to Joe, right? That's this reference referring to Joe. Now, here, if this thing were to take this P and assign the name to it to be Chris, suddenly the name of this guy will be changing from Joe to Chris. And this, when this returns, this one would still have a reference to that, and its name would be what? Chris.
But it's still the same guy.
It's still the same guy.
So it's still pointing, I mean,
Yeah.
and the point is
Yeah.
that it's not Chris, it's a guy
That's right.
with any number of attributes, including a name and maybe
That's right.
a
It's the
title.
same person that it was referring to earlier. We didn't magically change who this referred to. What we did do is we changed some attributes of that person. We changed some characters.
So what is the actual reference? Is it some like hidden ID number or like, you know?
Essentially, it's a hidden ID number. It's an ID number to some raw memory location in the computer. It's just a sort of number whereby you can find this information. And so you can think of it as like your social security number, as long as you can look it up in some way. It actually may be slightly more sophisticated than that, given garbage collection and so on, but I think that's that's the essence of how it's done. What's really important to realize, though, here is that this, whatever name we give it here, is immaterial as far as that's concerned. And nothing we do up here, like if we assigned a new reference to this one here, it's not in any way going to change what this one refers to. The fact that we call this P is not going to matter to this. We could have called it A, we could have called it Q, we could have called it whatever we want. And that's part of the design of Java, modern programming language. You don't want the vagaries of how you happen to name this to screw other code up.
And that's because while that top P exists,
Yeah.
I'm doing whatever I got to do right there.
You don't want to have to be thinking about the vagaries of how this was named. The person who wrote this doesn't have to, doesn't need to restrict sort of the names that these people happen to use in their code. What they use as their names is their business. What this one uses as name is their business. As long as there's a clear handoff of information, when you call something, all you're doing is you're passing values. You're passing a number, like 2, or you're passing a reference, but it's just a value. It's just something that's referring to this thing. And this code can assign subsequently to that variable that's associated with the information passed into it, but it doesn't change in any way sort of the things at the next level down. It doesn't change what their variables referred to. And yes, you don't want to have to know everything about the naming scheme that these persons use. So fundamentally, when you see, the reason I'm going into this is because some students of mine from health sciences background, they got really confused because they see two different methods, like, let's suppose like this method here, establish offspring connections based on mother's connections, and they suppose that it used offspring, you know, instead, or they saw that it used the same word for mother here, and they're not sure, you know, how does that relate to the mother down here? It really is not worth getting all worked up about how this mother is related to that one. The key point is that whatever information is passed, whatever value is passed, that's the second value when this call is made, is associated with a variable called mother here, and you can then assign to that or whatever. It's not going to affect the other mother. Does that make sense? And so there's this call stack, and one after the other they get built up on this call stack when these, and this is literally what's going on behind the scenes when you're running Java code. There's a call stack, and sometimes it may be 15 methods deep. You know, A calls B, calls C, calls D, calls E, calls F. And it's all because there's delegation going on. You know, simplifying your life by when you're writing the code, you don't want to worry about the details, so you just have it call off to something, and later you go about writing it. Now, there's actually very good reasons to do other things. There's other additional good reasons we'll be talking about maybe today, probably next time, on using what's called subclassing and subtyping, because you might not even know whose implementation it is that you're calling of my method or something like that until it actually is called. But suffice it to say, this is call stack built up. The upper levels don't know about the lower levels. They simply do their work and they return to it. The only thing they can do to interfere with the activity at the lower levels is they can change things in things referred to by the lower levels. That's what they can do. But they can't change magically the variables there. And one doesn't have to know about the variable namings of the other. Okay? So you're free to use whatever names you want here. Now, you will see this call stack sometimes. In fact, I'm going to make this call stack happen. I'm going to turn lemon into lemonade. And watch this. We're going to make this call stack appear in the most unpleasant of circumstances. So I'm going to run this. Do you remember what happened when I ran this before? I tried running what it looked like, and a rude surprise happened to me. Remember this? Okay. So it was an unhappy camper. Let's see what it complained about. Oh, look at that information. What do you think that information is? Let's go look at that up close.